Alright, hello. Welcome back. And this is the part 2 of the video from 18 to 29. So hopefully this one will be just as quick as the last one so you don't have to watch the video for a long time. Alright, here's number 18. Number 18 is segment addition. So we're going to take our 7x plus 1, add it to 4x minus 13. And we're going to set it equal to 44 because they told us that it was equal to 44. Add 12 on both sides. 11x equals 56. Divide both sides by 11. Of course, your calculator is going to give you a value of 5.090909. Please don't put that down. If you put 5.1 here, I'm going to mark it wrong, and I will not even look at these two answers. Because 5.1 is an approximation. The actual answer to this question is 56 over 11. So please keep it as 56 over 11. No mixed numbers. Mixed numbers are for middle school. Alright, the next thing that we're going to do is plug in 56 over 11 in for x. Wonderful thing about the TI is it can do all of this for you. And that's how we get 403 over 11. Now, if you choose not to use the TI, to simplify it for you, you're just going to have to multiply these two, and that's 392 over 11. That becomes 11 over 11. So another way to get 403 over 11. Okay, on this side you do 4 times 56 over 11 minus 13. So you do 4 times 56. That's 224 over 11 minus, now just multiply these two, 13 and 11. That'll give you the numerator. So minus 143 over 11. And once you subtract your numerators, that's how you get 81 over 11. Okay, please remember, I am very strict about grading these, so I don't expect to see this part, but I do expect to see this part that will lead to that part. Okay? Alright, that's 18. Alright, 19, you should know that angle 1 is congruent to angle 3. These angles are called vertical angles. And I think that was one of your vocab words, meaning that angle 2 is congruent to angle 4 because of the same reason. Now, the other thing you should notice is that 1 and 4 form a linear pair, which means that they are supplementary. That's going to help us for later. Alright, so they told us that measure of angle 1 was 9x plus 34, and they told us 3 was equal to 6x plus 45. They never gave us these two, so there's nothing else that we can do but set them equal to each other. So x is equal to 11 over 3. Please do not put on your paper 3.66666 because I will just take points off. So what you're going to do is for 2, we don't know what 2 is, but I know it's 180 minus the measure of angle 3. So I need to find the measure of angle 3. Which is 6 times 11 over 3 plus 45. Put that into your calculator. And that's 67 degrees. Again, don't forget the degrees. I will take points off. So now you're going to do 180 minus 67, and that gives you 113 degrees. Don't forget the degrees. Alright, number 20 is a midpoint. Remember, midpoint, cut your segment into 2 equal parts. So 12x minus 11 will be the same thing as 7x plus 48. So just set them equal to each other and solve for x. Again, I know if you put 59 over 5, you get 11.8, but please, no decimals. We have plenty of time to learn how to round decimals. Right now, we're working with fractions. So keep this as 59 over 5. So for AM, it's 12 times 59 over 5 minus 11. If you don't want to use the calculator to do it for you, you can just change that to 708 over 5 minus 55 over 5, and you get 653 over 5. But you could have put this all in your calculator and press math enter enter if you wanted to. Alright, remember AC equals the whole thing. So it is double AM. Remember that. Because you guys keep getting that wrong. So what you should do is 2 times 653 over 5 and just multiply. And you get 1306 over 5. You do it like this, you'll get full credit. You show me decimals, I'm taking a point off for each one. Alright, so that concludes all of the segment addition, midpoints, and angle bisectors. Now we're moving to the transformation section. Just as a reminder to you, I will write your transformations that you do need to know and study in your notes. You have a rotation of 180 degrees about the origin, and that's represented by negating both of them, both x and y. So if you started here, the rotation is going to bring you here. Okay. Next you have are your two reflections. Reflection over the x-axis, where x stays the same and y changes. And then you have reflection over the y-axis, where x changes and y stays the same. And then we have number 24, which is reflection over the line y equals x, and that just means that you're going to change the position of x and y. So if we were actually going to plot that reflection, this is the line y equals x. If you don't believe me, put it in your calculator. So basically what the rule is saying is that if I'm here at 1, 2, that the reflection over that line will put me at 2, 1. See, it reflects right over that line. So that's what this is saying here. Alright, so, and then of course this is your reflection over the x-axis, reflection over the y-axis. Last one is your translation. Over AB, and that's x plus A, comma y plus B. Which means that if you start here, you're just moving in a certain direction to your next space. Alright, so this first one, if you were to rewrite it, it's rewritten as x minus 5, which means that I'm moving to the left. Y plus 2 means that I'm moving up. So I translate left 5 and up 2. The next one is clearly my rotation. So all that is a rotation of 180 degrees about the origin. Okay, this next one is a combination. If you look at it closely, This part right here represents the translation. And then this part right here represents a reflection. So when you have a reflection and a rotation together, that combines to be a glide reflection. So a reflection and a translation together is a glide reflection. So when you're explaining the glide reflection, you have to explain the two things that happen. So not only did it translate, this tells you it's going to the right 4, but then this negative y tells you that we wind up reflecting over the x-axis. Okay, the last one is the new rule that I was telling you about, which is over this line, which we call y equals x. So when you switch the x and the y, that's just a reflection over the line y equals x. Alright, so those are all of your transformations. You have to know them like the back of your hand. Alright, this next one, not only did you have to transform, but you also had to write down the coordinate. So our original coordinates, we know that A is -2, -1, B is 0, 4, and C is 3, 0. So now the first thing that you're going to do is you are going to rotate 180 degrees about the origin. So you're basically going to take this picture and flip it upside down around the origin. So that means that A prime becomes 2, 1. B prime becomes 0, -4. Notice I'm changing the signs of both coordinates. And C prime becomes -3, 0. So here is C prime. Here is B prime. And here is A prime. Okay, so when I connect my dots, there is my rotation. So if I put my pen right here in the middle and I flipped my paper upside down, I should be able to see that it's the same picture, but it's just been flipped upside down. Now, this is the part that you guys have been getting so confused on. When you translate or rotate or reflect, you have to go from original to new. So this is the original, this is the new, and then you have to go from new to what I call the new. Okay? So you never go from original to new. Okay, so for the new one, which is a double prime, it's right 3 and down 2. So that means I'm adding 3 and subtracting 2 to each coordinate. Okay? Adding 3, subtracting 2. Adding 3, subtracting 2. Okay, so notice who I added 3 and subtracted 2 from. Not from the original, but from the new. So I'm going to go to 5, -1, and this is my new A. So I'm going from A prime to A double prime. And then 3, -6. That's my new B double prime. And then 0, -2. That's my new C double prime. So now when I connect my dots, I should be able to count from A to A prime, and it should only be to the right 3 and down 2. Yep. And from here, right 3 and down 2. Yep. And then from here, right 3 and down 2. And that's what should have happened in your picture. So now it says describe the transformation. That means in words, say what happened from original to new to new. Okay, so basically from original to new, we rotated 180 degrees about the origin. And then from new to new, we translated +3 means right 3, and we also went -2, which is down 2. Now, it didn't ask you to write the rule, but if you were to write the rule for this, because you should know how to write the rule would be -x plus 3. Here is your rotation, here is your translation, and then -y minus 2. Here is your rotation, here's your translation. So you're basically taking these two rules and putting them together. But they didn't ask you to do that, so. But if they do on this test tomorrow, make sure you know how to do it. All right, the last question, 29, which probably should have been question 27, is basically saying, how can he find the approximate location that is equal distance to all the locations, and how can he verify it? All right, so they're not asking you to do it. So when you actually do your perpendicular bisectors, and I'm just going to do 2 because when you do perpendicular bisectors, it's not required you to do more than 2. And mine might not be perfect because I'm just sketching. But what would happen is that you would take this circumcenter, right? And after you create your circle, like I said, this is not going to be perfect because it's just a sketch. But of course, you would have a compass and all of that. And what you would do is you would take a ruler and you would take that ruler, because they said, how can you verify it? So you would take the ruler, if I could turn my ruler. Anyway, you would take the ruler and you would measure all of the radii. These are radii. Radii are lines that go from center to circle. And you would measure all of the radii. Now, if all of the radii are the same distance, then your circumcenter is in the right spot. What you would also do, because these points are on the circle, you can create radii that would go from the circumcenter to each of the vertices. And then what you would do is take your ruler and measure how far apart these are. And if they come out to be exactly the same, you did your picture right. Now, of course, my picture is not going to be perfect because I did not use a ruler, I didn't use a compass, but I just gave you a basic idea of what the picture would look like. So to answer the question, how can you find an approximate location of equal distance? He would do the perpendicular bisectors, and he would use the perpendicular bisectors to create a circumcised circle. And then the circumscribed circle. And inside the circumscribed circle would be an circumcenter. And the circumcenter should be equal distance to all of the vertices of the triangle. Vertices are points. Okay. Now, if the question asks you about, okay, so there's some things that you might need to know that might not be on your review. Like incenters. We didn't really talk about incenters a lot. So the incenter of an inscribed triangle, so you should probably write this down somewhere, okay, is equidistant to the sides of the triangle. So it's kind of opposite of the circumcenter. So it's different from the circumcenter. Circumcenter goes with points or vertices. Incenters go with sides. And it's also the intersection the angle bisectors. So incenters, inscribed angle bisectors, sides. Now if you want to change the sentence so that it's about circumcenters, circumcenter of a triangle, of a circumscribed triangle, is equidistant, which means equal in distance to the vertices of the triangle and also the intersection of the perpendicular bisectors. Now this whole entire definition was written for you in your notes, and also we did a nice little activity with the patty paper. Now, when we're talking about circumcenters, there's 3 different circumcenters that you should know. And we kind of touched on this a little bit. Okay, so the circumcenter of an acute triangle is in the center, okay? Well, not the center, but it's inside. The circumcenter of a right triangle is actually right on the triangle. So the circumcenter of an acute triangle is inside. The circumcenter of a right triangle is on there. And then of an obtuse triangle, it's on the outside. Now we did actually go over this briefly with the 1.5 classwork worksheet, but I don't know if anybody was paying attention. So, and I know you guys forget things sometimes. So make sure you know that. Alright, so hopefully that covers mostly everything that's on the test and the review that you need to be covered. If there's anything else on the test tomorrow that looks a little confusing, just make sure you read over the question again and just make sure you really concentrate and take your time. And make sure you read your notes, because a lot of things in the review might not be on the test, but everything from your notes is. So make sure you read your detailed notes and study, redo the review, and just try to do your best. All right, good luck, everybody.